All right, guys, so this was just a review of what we did last week. I asked you guys to find the inverse relation and the inverse function of the following. And notice that number one, I gave you a bunch of ordered pairs. And what really ordered pairs do is just a quick hand way of showing you a relationship between an input and an output. So more specifically, if you see this ordered pair, what gets listed first, an X or a Y? Your X. And then what gets listed second? Your Y. Remember that your X's are really just inputs and your Y's are outputs. So notice that when you have a list of ordered pairs, they're just giving you a bunch of inputs and outputs. Now, you don't know what the equation is or what the exact relationship is, but you know that if you input 1 into whatever equation, you're going to get a negative 3 out. When you input a negative 2, you're going to get a 3 out, and so forth, right? Now, this is what I like to call, or what all math people call, a relation. In order to find the inverse relation, what you need to do is you need to switch each of the inputs with the outputs, or each of the x's with the y's. So this is a little straightforward when dealing with ordered pairs because, again, all you have to do is switch the y's with the x's. This becomes negative 3, this becomes a 1, this is 3 and negative 2, and this one becomes negative 11 and a positive 5. Okay? Does that make sense? Again, that is just by definition. Now, when you're finding the inverse relation, all you're doing is switching your inputs with your outputs. Now, in terms of functions, it gets a little more complicated. There's a little more deeper understanding. Because although we didn't know about the relationship in the beginning of these ordered pairs, we didn't care because all we needed to do was switch our x's and y's. Now, this is focusing on the relation. Like any other relation that you have or any equation, you can input something and get an output. I want you to come up with the inverse function. I want you to come up with the function that when I plug in the output, I get the input. So I wanted you to reverse it. Now, I know it sounds a little complicated, but it's a little more straightforward. Remember that when you're finding the inverse, you're just switching your x's and y's. This is just a fancy way of writing a y, the f of x. So let's switch it back to y. Y is going to be equal to a negative 2x minus 1. Now, keep in mind that this is just a fancy way of, again, of writing the y. So all I did was rewrite it. And now I'm going to actually find the inverse function by switching my x's and my y's. This is a y, so now it's an x. This is an x, so now it's a y. Now, this is the inverse function, but no one ever wants their function written without the y by itself, isolated. So you have to solve for the y after you switch your x's and y's. Always get rid of what you're adding and subtracting first. So I'm going to get rid of that 1 by adding 1 to both sides. You end up with x plus 1 is equal to a negative 2y. Now, solving for that y, what you have to do is divide by negative 2. Now that your y is isolated, you can see that you end up with y is equal to an x plus 1 all divided by a negative 2. Now, you always have to remember that because we started with function notation, you have to switch your y back to that function notation. So let's switch it back to f of x. Then you also have to remember, hey, I have to tell the reader that this is my relation and this is my inverse relation, which is pretty straightforward because all you have to do is add that little negative 1. By adding that little negative 1, you're telling the reader, hey, man, this is the inverse of this function. So, again, relation, inverse. Now, the biggest thing that you could always do to kind of check to see if you did it correctly is check any input. Put an input into this equation and see what the output is. And if you plug in that output into this equation, you should get the input. It should work backwards. Let's go ahead and try that. So let's go into my relation. Let's plug in a 1. What is a negative 2 times 1? Negative 2. Negative 2 minus 1 is a negative 3. So notice that my x value is 1, my y value is negative 3. And again, the inverse just helps you work backwards. So let's plug in a negative 3 and hope that we did it correctly to get a 1 out. And you can see if you plug in a negative 3 plus 1 is negative 2. Negative 2 divided by negative 2 gives you that positive 1. So again, to me, it's more like a roadmap helping you work backwards type of thing. Okay? All right, so that is really important for today because today we're really going to study a very specific inverse function. It's a very, very specific function that you guys probably have heard about before, and it is called the square root function. Now, before we get to the square root function, let's use this relation to help us figure out a little bit more information about it. So the first thing I want you to do is complete the following table and graph the following functions. So for f of x is equal to x squared, I want you to fill out the table. It's very straightforward because all you're doing is plugging in negative 3 into an x squared. What is negative 3 squared? Remember, a squared, negative 3 times negative 3 is 9, right? And what is negative 2 squared? 4, negative 1 squared? 1, 0 squared? All right, I think you guys get the point, right? So I'll let you guys finish this table. I'll go along and finish it as well. Also make a really quick sketch of the graph. And then find the inverse of this function. Fill out the table for the inverse and the graph. Remember your relation. See if he can help you make this a little quicker. All right, guys, so let's go over this one really quickly. So notice that what we're really doing here is we're starting off with something that we already know. Now, we have some experience with quadratics, right, with parabolas. We spent a whole unit and a half on this stuff. And what we're really doing today is really studying the inverse function of a quadratic, which you'll find out a little bit is a square root function. Now, notice that I filled out this table for this specific function. Now, let's go ahead and find the inverse. And I'm going to do it over here to the right. I'm going to change this f of x to y because, again, f of x is just a fancy way of writing y. And now I'm going to actually perform the inverse. So I'm going to switch my x's and my y's. So I end up with x is equal to y squared. Now, just like the other inverse functions that we found, we have to have our y isolated. So what's the inverse function of a square? What's the opposite? How do you undo it, the inverse function? Square root, right? Do you guys remember the square root? Now, if you're ever the one doing the square root, there's a little thing that I told you to not forget about, and that is to take the plus or minus. Remember, whenever you're the one taking the square root of anything, there's always two solutions, a positive and a negative, and that is why I included a positive and negative there. A square and a square root cancel out, so notice you're left with y is equal to plus or minus the square root of x. I'm going to change this y back to f of x and also include the negative 1, and then you can see that my inverse function is a negative x. Now, keep in mind that I found the inverse function. So instead of just finding random numbers to plug in here, I technically already have a whole table of values. Because remember that each one of these represents an input for a specific output. Specific input for a specific output. So if I'm trying to find a table, what can I just do? You could flip these, because remember, this is the inverse of this specific relation. So if I have the point negative 3 and 9, this would transfer over as 9 and negative 3. This point, negative 2 and 4, will transfer over as 4 and negative 2, and so forth and so forth. So I'm going to go ahead and do that as well. And then I'm going to go ahead and actually graph these as well so I can relate these two together. All right, so what we have here again is we started off with this function that we already had a lot of experience with. which is this quadratic. And we filled out the table for the quadratic. We saw this graph, which was a parabola. Now, what we're going to study today is the inverse function. So in order to help us kind of expedite things, we just flipped our table, our x and y's values, because we know if it's an inverse, you're just switching your x's and y's. Once I plotted the points, I can see that I ended up with the sideways parabola-looking thing, which makes sense because remember, it's always going to flip over the y equals x axis. Now, does everyone remember what it means to have a function? So in order to have an actual function is a relation where every input, aka x value, has exactly one output / y value. So what does that mean? Well, if I look at this graph here, notice that this is a function because there's a simple test that I could give it in order to figure out whether it's a function. It is called the vertical line test. And it's really easy because all you have to do is draw vertical lines, as many vertical lines as you can. If it crosses your graph more than once, it is not a function. And if it crosses everything only once, it is a function. So looking at this, is there any vertical line that I could draw and it's going to cross this graph more than once? No, so it's a function. But how about my inverse function? Can I draw a line and it crosses more than once? Yes, so is this a function? No. So what math people did is instead of just forgetting about it and not calling it a function, they were like, we're just going to ignore the negative part. So what they did there is like, okay, if I ignore the negative part, it's always going to be the bottom, and I'm just going to study that. And that is why you arrive to something that's called the square root function. That is why the square root function technically is the inverse function of a quadratic. The only difference is that we only have half of it. So it's kind of like a little caveat there. In order to make it a function, we're just going to let half of it go or something along those lines. Okay? And that's our goal today, is to pretty much learn how to graph these functions. All your graphs should have a half a parabola shape, which is half of a U, I guess you would describe it as. All right, you guys getting ready to start on how to graph these? Okay. So notice I'm kind of taking a break from where the square root function came from. I'm hoping that you guys know that it just came from a quadratic function. Now we're going to start concentrating on the square root function as it by itself. We're going to study on that alone. Now, does everybody remember what domain means? What is the domain of a function? Remember we went over this like the first 2 months of school? Everyone remembers that like it was yesterday, right? Back in September or October. Well, let me remind you. Whenever we're talking about domain, what we're talking about are the x values, aka the inputs of a function. So if I look at this function here, notice I have f of x is equal to the square root of x. There are certain kind of values that you can plug into this function without getting an error or without disrupting the rules of math, so to speak. Now let's think about this. I know that my input are the values I can plug in for x. What are things that I can take a square root of? Can I take the square root of 0? I would say so. Can you take the square root of a positive? Yeah, sometimes you're going to have decimals and sometimes you're going to have whole numbers. Can you ever take the square root of a negative? No, right? Because what is the square root function asking you to do? It's asking you to come up with a number that multiplies itself to equal the inside. So let's say I have my favorite number here, negative 9. Does there exist a number that is not imaginary that multiplies itself to equal a negative number? No, because even if you think of 3 times 3 is a positive 9. If you do negative 3 times negative 3 equals a positive 9 as well. You can never multiply something by itself and get that negative. So whenever you have a square root, you know when you talk about the domain, everything underneath the square root, which what I like to call a radicand, has to be greater than or equal to 0, aka your x of your function, everything underneath has to be greater than or equal to 0. Now, if you know that all your x values have to be greater than or equal to 0, that's the x values you're going to start plugging in your value. Now, after you plug in your value, you're going to need to analyze your domain. Your x values have to be greater than or equal to 0, so you choose any other value, plug it into your equation, and you can go ahead and solve it. Keep in mind that when you graph your guys' square root functions, you're always going to get half of that parabola. But of course, depending on what your domain is and what values you can plug in are going to pretty much dictate what your graph is going to look like. Okay, a little bit. Let me show you what that means with a very specific problem, and I'll bring the range into there at that time too. All right, so I want you to graph the following function. First thing that I want you to notice is that you have a radical there. You have a radical. Now, what is true about the radicand, aka everything that's underneath the radical? What is true about the domain values in regards to that radicand? It always has to be greater than or equal to 0, because you know you can never take the square root of a negative. So what values make this greater than or equal to 0? What makes it positive? Well, let's set this everything underneath the radical, aka the radicand, greater than or equal to 0, to solve for what x values we could plug in. That should be your first step in being able to find the domain, because that's really the only thing that holds you back in terms of plugging in values. Now, solving for this, I'm going to solve for y. So let me go ahead and minus 4 on both sides. I end up with 2x is greater than or equal to a negative 4. Finally, I'm going to divide by 2 on both sides. I'm going to end up with x is greater than a negative 2. Now, what does this mean? This means that your domain has to be greater than or equal to negative 2, aka your x values, your inputs. The values you plug into this equation have to be greater than or equal to negative 2, because if they're not, you're going to end up with an error inside of this radical. Now, let me show you what that means. What's something that is not greater than or equal to negative 2? Negative 3. 2 times negative 3 is negative 6, plus 4 is a negative 2. Can you take the square root of a negative 2? No. Your values have to be greater than or equal to negative 2. Now, if I'm trying to fill out a table, I know this is the first x value I could start off with. It's my job to plug it in and figure out what I get out. So let's plug in a value and see what we get. F of 2, negative 2, to be exact, is equal to the square root of 2 times negative 2 plus 4. Now let's do the math within the square root. 2 times a negative 2 is a negative 4. Don't forget to add the 4. Don't forget that's all underneath the square root. Negative 4 plus 4 is 0. What is the square root of 0? 0. So you found your first point of your graph, which is right over here. Now let's plug in another value just to get the shape of the graph a little bit better. Now, what are values that I could choose? Anything that's greater than or equal to 0 doesn't really matter. Which one do you guys think? 0 is a great one because, again, doesn't matter. Just try and find the general shape of the graph. Choose something that's easier. If you plug in 0, notice that you can kind of predict that's going to be a little easy to deal with. Does it mean you're wrong if you would have chose 3, 4, 5, or something else? No, as long as you choose something that's greater than or equal to a negative 2. So f of 0 is going to be equal to the square root of 2 times 0 plus 4. Doing the math, 2 times 0 is 0. Don't forget to add the 4. 0 plus 4 is 4. Don't forget to take the square root, which gives you a positive 2. Now remember that the shape of a square root is just half of the inverse of a quadratic. So it's going to give you that little U shape. Now remember, this is your starting point. That's where your domain starts. So you know that from this point to this point, they're going to be connected. And then you can just make the U shape after that. Now let's talk a little bit about range. Now the domain are the x values, so what do you think the range is? The y value. So let's look at this graph here. If I am concentrating on my y-axis, which is the one going up and down, what is the very least y that this graph touches? Where does this graph start existing? Does it exist anywhere down here? No. Where does it start existing? The y-axis, right? Well, technically it's the x-axis, right? Because it's up there. And what is this y here? 0. And it's going to exist everywhere above it. So if I were to describe my range of this graph, it'd be where y's are greater than or equal to 0. Now, can anyone kind of take a hint of what that y value is always going to be? It's always going to be the y value of whatever you plug into your first domain value, because again, that's where really your graph starts. It kind of shows you where the beginning point of it is. And this is what I want you guys to be able to do. If I was to kind of come up with the game plan, first thing I would do is understand that everything underneath the radical has to be greater than or equal to 0. Once you understand that, you can solve for it, you can start your domain, you can go ahead and start your table. After you plug it in, you can go ahead and you pretty much found your range, which I'll do in green. And then after that, you'd be able to choose whichever point is and get the general shape of your graph. And that's all I want you guys to be able to do today. If you can do that, I'll be pretty confident. Let's do this one real quick. So let me game plan this up a little bit. All right, guys, so let me go over this one. That way I give you guys your practice. That way you guys can get as much individual help as possible. So first things first is understanding what we're doing. What we're doing here is we're graphing square root functions. Now, keep in mind that the values that we can plug into our function are 100% dependent on the radicand, aka everything underneath that radical. Because remember, you cannot take the square root of a negative. If you take the square root of a negative, you're going to get an error. Nothing good turns out. So pretty much what we're doing is like, okay, so where does my graph start? Well, it starts wherever everything inside your square root is positive. Now, that means that everything underneath this square root, 2x plus 1, has to be greater than or equal to 0 for it to exist. Because if it doesn't, that means it's negative. So let's go ahead and solve for this equation to find the specific x values that will make sure that this is positive. So let's go ahead. Minus 1, you end up with 2x is greater than or equal to a negative 1. Divide by 2, x is greater than or equal to a negative 1 over 2. So again, what did I do? I set everything underneath the radicand, everything underneath the radical, greater than or equal to 0. I didn't care about the 5 because the 5 has nothing to do with what is inside of the radical. I said greater than or equal to 0. I solve for it because those are the values that make this positive or 0 or bigger. Now, that is what my domain values are. Those are the values that I can plug in. So that should be the very first x value that you plug into your equation, which is a negative 1/2. Now let's go ahead and plug in that value to see what its associated y is. Now, I'm going to do this over here so that way there's a little more space. It's the square root of 2 times whatever x is, which is a negative 1/2, plus 1. Don't forget to add 5, which is outside of your square root. Now, what is 2 times a negative 1/2? Half of 2 is 1. Don't forget the negative gives you that negative 1. Plus 1. Negative 1 plus 1 is 0. The square root of 0 is 0. And finally, 0 plus 5 is 5. So when you plug in the negative 1/2, you get a 5 out. So notice that's the start of your graph. Now, putting these two together, negative 1/2 would roughly be right about here, and then 5 would be 1, 2, 3, 4, 5. Right about there as much as possible that I can. Now, remember, when you're figuring out what next x values you can input into your equation, what is true about the domain? It's telling you what inputs you can input. You can only input x's that are greater than or equal to negative 1/2. So what's the very next value that makes a little bit more sense in terms of plugging in? What should be the next value that's greater than or equal to negative 1/2 that we should plug in? I don't know, what do you think? 0 worked last time. Should we try 0? Why not, right? Now, can we try 2, 4, 5, 6, 7, 8? Yeah. Again, you can kind of depict with the square root. If you plug in a 4, 2 times 4 is 8, plus 1 is 9, square root of 9 would be 3, so forth and so forth. You'll still get whole numbers, but you can also use your calculator. This is going to be totally legit for this one. So let's go ahead and plug in a 0, just because it makes a little more sense. So square root of 2 times 0 plus 1 plus the 5 on the outside. 2 times 0 is 0. Notice you have 0 plus 1, which equals 1. Square root of 1 is 1, plus the 5 finally equals 6. So when we plug in a 0, we get an output of 6, which if we were to graph, is located right here. And you can see that there is my little half of a parabola, and that is it. Now keep in mind that in your guys' homework I said x and y intercepts. Don't worry about those right now. I just want you to be able to find the domain, the range, and get a general shape of the graph. With that being said, let's go ahead and talk about our range. Our range are the y values. Where does this graph start to appear? Am I scratching any part of the graph out? No, until I get to this value here, which is what? 5. Now, is your graph above the green or below the green? Above. So that means that your range is where y is greater than or equal to a positive 5. And that's pretty much it.